Good day, students. You're welcome to the continuation of your screencast on week 8's work on integration. Today you shall be looking at definite integral. In definite integral, you will be doing integration, but you'll be given values which your integral expression covers, from the minimum value of x to the highest value there of x. So let's see an example. Here we have integral of 2x cubed dx from 0 to 1. So the first thing to do is to integrate that. So I add 1 plus 3 gives me 4. I divide by 4. And that gives me that. You add your constants. You still leave your 1 and 0 there, which is your range at which the curve covers. So it means this covers the range 0 to 1, values of x to 0 to 1. So it means what I need to do now is to substitute for 1. You start with the larger number there, and you subtract from 0 as a substitution there for x. So if I do that, I've opened the bracket there, open the bracket and then subtract, you have half. That is the answer to that. So what we are saying is that in definite integrals, we are looking for area more or less under that curve, and that gives us within 0 and 1, and that gives us half. So it means area covered by that curve between 0 and 1 is half. Let's look at example 2. Here we have integral of 1 over x dx between 2 to minus 4. Sorry, between 2 to 4. So what we do now is we integrate that. Don't forget that integral of 1 over x is ln x plus c. Still leaving your 4 and 2 there. By the time you have finished integration, you don't put the integral sign again. Remember that. And then now you substitute for 4 for x. And then you subtract, you substitute for 2, the second value of x. And then ln 4 is your natural log 4 minus natural log 2. In your calculator, if you do that, you're going to have 0.69. You can leave it in 2 decimal places. Let's look at example 3. Still on definite integral. Here we have x into bracket x squared minus 1 dx from 0 to 1. I can open the bracket here since the power is not so large, and then I can now integrate them separately. So integral of x cubed is x to the power of 4 divided by 4. Integral of x, since the power is 1, it becomes x to the power of 2 divided by 2 plus c. At this point, I need to now substitute for 1 first, the larger number. Put 1 for x there, you have that. And then I'll say minus, put 0 there, the second value of x. And then when you put that in your calculator, you're going to have negative 1 over 4. Sometimes you can have values of negative answers. Example 4, still on definite integral. Let's integrate that. Now when you look at the situation where you have a higher power like 3, 4, 5 and so on, you must remember that you can only use the substitution method, which makes it easier. And so I will let u equals to that, as you can see there, and I will differentiate my u with respect to x, and that gives me 2x. So I will solve for dx because I've already replaced it by u. So if I solve for dx there, by changing the position of dx and 2x, I'm going to have du over 2x equals to dx. So I go back to the expression and I put u there, since I've represented as u. My dx also will change to du over 2x, which is that there. Then you can simplify. The 2 will cancel with 8, which gives you 4. The x will cancel out, and then you're going to be left with 4u to the power of 3. At this point now, I can now integrate. If I integrate, I add 1 to that, it gives me 4, and I divide by 4. So it means I'll be left with u to the power of 4, and I will add my constant. My 1 and 0 will stay be there because I've not used the values yet. So before I use that, I can substitute by my u as x squared plus 1, and that's what I've done there. And then now I will substitute my x values, 1 first, and then you now put 0 there, you minus that. If you do that with your calculator, you should be having that. Because this is going to give you 1 plus 1, that gives you 2, 2 to the power of 4 is 16, minus 1, which gives you 15. Let's look at another example. Here we also have that x squared times cube root of 7x cubed plus 1 dx. So in this case also I'll use the substitution method. Let u equals to that under the root sign. Differentiate that with respect to x. I'm going to have 21x squared. Solve for dx. Dx will be du over 21x squared because that's when we just changed their position. And so what I will do next is replace that with u. It becomes u to the power of half, because, sorry, to the power of 1/3, because it's a cube root. And that's your x squared there. And then my dx, I will replace it with what? du over 21x squared, which is there. And so at this point, you cancel out the x squared. We will left with this 1 over that. So I remove 1 over 21 because it's a constant. I'll now only be integrating that. If I integrate u to the power of 1/3, it's going to give me u to the power of 4 over 3. Divide that by 4 over 3, it becomes 1 over 28. So this is going to give you 4 over 3 when you add 1 to that. And if I multiply this by 3 over 4, it gives me that. And then from there, you can now substitute back your u as that. And that gives you, so if I put 7x cubed plus 1 there, and I now put my expression of x as 1, that's what I've just done there. It gives me that. Okay, this should be, sorry for that, this should be 7 into bracket 1, and then I have to the power of 3. That should be the right thing. Sorry for that. And then you add 1. And then you do the same here. This becomes 7 times 0 to the power of sorry for that, to the power of 0, sorry, to the power of 3 over 3. And then you have plus 1. Your answer should be different from that. This should give us 7 plus 1, that gives us 8. So it means 8 over 28, because here you're going to have 0 as a result of the 0 here. So it should be 8 over 28, so let's write that there. Okay, that's all about that. Thank you.